All right, cruising right along. Now we have a deck. That's a rectangle. Okay. The diagonal of this deck, and which diagonals are really important. I'm going to talk about that a lot in the later unit, but they're incredibly important because they guarantee right angles if certain things happen. All right. So we know the diagonal of the deck is 41. We know this number's 9. We need to find this number so we can find the area and perimeter of the deck. All right, so let's use Pythagorean theorem really fast. X squared plus 9 squared equals 41 squared. X squared equals 81, or plus 81 equals 4,081, I think. Let me double check. Or hold on, complete brain fart. 16,081. Subtract 81 from both sides. X squared equals 1600. The square root of both sides, x equals 40. All right, so we have a deck diagonal 41, a width of 40, or a height width of 40, and a length of 4, width of 9, and a width of 40. All right, so now we need to find the area. Remember, the area of a rectangle is just base times height, which is going to be 40 times 9, 360. And then the perimeter is just going to be 2 times 40 plus 9. All right. That's one way to do perimeter. Or you could have done 40 plus 40 plus 9 plus 9. 40 plus 9 times 2, 98. All right. And we should have done feet and feet squared. All right. Now, based on the 3 sides lengths you are given, classify the triangle by sides and then the angle. So remember, let's see, I'm going to skip this one, and this one. All right, don't want to make the videos too long. Anywho, remember you must first do the triangle inequality theorem. Then you do Pythagorean theorem. So you must first realize that determine if it makes a triangle, and then see what kind of triangle it makes. So doing the triangle inequality theorem, you're going to pick the 2 smaller sides. 3 plus 4 equals 7, greater than 5. So check, it can make a triangle. Next, you plug it into Pythagorean theorem. 3 squared plus 4 squared. You're not going to write equals or anything yet. You're just going to compare it. We get 25 on this left-hand side. We get 25 on this right-hand side. So it makes a right triangle. All right, so we know it makes a right triangle since Pythagorean theorem worked. And since none of the lengths are the same, it's scalene. And actually, let's do this. I want to do number D, and we'll skip number E. All right. Again, let's do triangle inequality theorem. 6 plus 7 equals 13, greater than 8. So check, yes, it can make a triangle. Cool. Next, we're going to plug it into Pythagorean theorem and see what happens. 6 squared plus 7 squared. You're going to get 36 plus 49. 36 plus 49 equals 85. You're going to compare that to 8 squared, which is just a measly 64. So since it's bigger, so recall if a squared plus b squared is greater than c squared, it's acute. All right. So based off this fact, none of the side lengths are the same. So again, scalene, and then acute, or an acute scalene, whatever you want to call it. And then over here, 2, 4, 7, plug it in triangle inequality theorem. 2 plus 4 equals 6. To say 6 is greater than 7 is straight up stupid. All right, not a triangle. Okay, so now we got some similar right triangle stuff. So we're going to solve for the indicated variable. We're going to leave your answer in simplest radical form if needed. But remember, we have 3 triangles. We have the small triangle, the little baby triangle, I like to call it, the medium triangle, and then big bad triangle, the mammoth. All right, so what you need to think is, which triangle do I know 2 side lengths of, and x does count? All right, and this one right here, well, looking at the little itty bitty baby triangle, I know it's kind of hard to tell, but this is the short leg and this is the long leg. All right, so I'm going to write short leg over long leg. And then specifically, I'm going to write 6 over x. That's going to help me keep my work organized. Next, in this medium triangle, yes, x counts. X is now the short leg. That's the long leg. So then I'm going to write x over 10. All right. So this is legal. Set them equal to each other. Cross multiply. I'm going to get x squared equals 60. Realize how when you cross multiply, you get rid of the fraction. I've seen a lot of you guys cross multiplying, and you're writing some silly stuff like x squared over 60. Don't do that. That's dumb. All right, that's not what we cross multiply for. It still equals. There's still an equal sign, and the whole point is to get rid of the fraction. All right, then I got to take the square root of both sides. The square root of 60. What's the largest square factor that goes into 60? Well, it has to be 30 or less. 25 doesn't work. 16 doesn't work. It's actually 4. Radical 4, radical 15, and we get 2 radical 15. Okay? In this one right here, number B, you might hear my dogs in the background. I'm on my deck making this video. But nonetheless, in this baby triangle, I have the hypotenuse, and we'll call it short leg. Kind of hard to tell. I don't know, I think they saw a leaf blow or something. I think they're barking at a leaf. All right, and then in this big triangle, short leg, and then the hypotenuse, realize it's 13. All right, the whole thing, the whole hypotenuse is 13. So again, it doesn't matter. I can do h over SL, SL over h, does not matter. I'm going to have y over 5 equals 13 over y. Cross multiply, you're going to get y squared equals 65. Hopefully this barking is helping you remember the math. So when you're doing the test, you guys can just recall my dog barking, and it'll help you remember the exact stuff. So it says simplest radical. 65 is actually exact. It cannot be simplified. There's no perfect square factors, and then this is a rounded answer. All right, so it said keep in simplest radical form. That would just be radical 65. I did 8.1 as a rounded decimal just for fun. All right.